Let's talk about coterminal angles. Here I have the definition. Basically, a coterminal angle are angles that are in standard position. And standard position just basically means that your initial side is right here along the positive x-axis. And the angles have the same initial side and the same terminal side. You can find different coterminal angles by either adding rotations of 360 degrees or subtracting rotations of 360 degrees, which is, of course, also 2 pi. So let's look at examples of 3 different coterminal angles. Let's start with the most basic. Let's do a 60-degree angle. All right, so we have this 60 degrees. This is just a basic example to start with, basic angle. Okay, now let's find a coterminal angle. So remember, coterminal angles have the same initial side and the same terminal side. Okay, so a different one would be if we started at 0 and we decide let's do a whole rotation, a whole 360 degrees, and then an additional 60 degrees. We basically had 360 degrees, that was our circle, plus another 60 degrees. That adds to be 420 degrees. So this is a 420 degree angle. Okay, different angles, but they're coterminal because they have the same initial side and the same terminal side. Okay, so let's find one more angle that's coterminal. So let's start with the same initial side. We know we have the same terminal side. This time, let's go in the negative direction. So if we started at 0 and we went around, ending right here at that terminal ray, this is a negative angle, but they are coterminal because they have the same rays, initial and terminal ray. So here, we basically went in the negative direction. This is a negative 300 degree. And the way I think about getting it is if I had the whole circle, which was, let's see, a 360 degrees, yet it's not a whole circle, so we can subtract off 300, subtract off a 60 degree angle. This is how I got 300 degrees. Of course, I'm writing that as positive, but since we went in the negative direction, it's a negative angle. So that's how I got it. But these are 3 examples of coterminal angles. Okay, if we are given an angle that is larger than 360 degrees or maybe a negative angle, we need to be able to find, as we word it, the least non-negative measure that's coterminal with this angle. That's basically saying we want to find an angle that's in between 0 and 360 degrees or 0 and 2 pi. So if it's larger, like example 1, 845 degrees is clearly larger than 360 degrees. We need to find a coterminal angle. And you can do that simply by subtracting off rotations, which is a whole circle. So remember, a rotation in degrees is 360 degrees. So for this first example, if I have 845, let's subtract off a rotation. If we subtract off 360 degrees, we get 485. 485 degrees, that's equal to. Okay, but we are left with 485, which is clearly still larger than 360, so we're going to take 485 and we're going to subtract another circle, or another rotation. And when we do that, we get 125. This produces a coterminal angle, and it's positive, which is the least non-negative, and it's in between 0 and 360 degrees. That's what we want. And let's look at example 2. We have negative 253 degrees. We're trying to find the least non-negative, so we need to basically find the smallest positive angle. So since we have a negative angle, we're basically going to just add rotations. So let's add 360 degrees to it. If you add 360 degrees to it, you get 107. And that's good. That's what we're looking for because we have a non-negative angle, and it's in between 0 and 360 degrees. Okay, let's look at pi, example 3 and 4, because most of the things we're going to deal with in trig are going to involve radian measures with these pi, so we need to really work on this. So here we have 14 pi over 3. This is clearly larger, so if you think about 2 pi, and you did it in terms of a common denominator, 2 pi is the same as 6 pi over 3. Right? And 14 pi over 3 is clearly much larger, so let's start subtracting things off. So I'm going to subtract one rotation, and remember a rotation in radians is 2 pi, it's one circle. Okay, so we have to convert this. Since we're subtracting its fractions, we have to get a common denominator. So let's say 14 pi over 3. 2 pi, let's convert that. that would be 6 pi over 3. All right, so when we subtract that, what do we get? We get 8 pi over 3. Okay, and we're looking for the smallest positive angle. Remember, 2 pi is the same thing as 6 pi over 3, so we're still a little bit larger. So let's take it, 8 pi over 3, and let's subtract one more rotation. All right, another 2 pi, which that is 8 pi over 3. And converted with the common denominator, 2 pi is 6 pi over 3. When you subtract those, 8 pi minus 6 pi is 2 pi over 3. Remember, when you're subtracting, you treat that pi kind of like you treat an x. If you're subtracting, like if you're subtracting 8x minus 6x, you just subtract the numbers and the x comes along. Same thing with the pi. 8 pi minus 6 pi, you just subtract the 8 minus 6, and the pi just comes along with it. So my answer is 2 pi over 3. This is in between 0 and 2 pi. Okay, let's look at number 4. We have negative. So once again, just like number 2, when we were talking about degrees, if we have a negative angle, we have to add rotations. So let's add 2 pi. Let's convert it because we have to have common denominators. So if I have negative pi over 60 plus, and converting that, if we have a denominator of 60, that would be 120 over pi. Okay, so now think, negative pi, that's the same thing as negative 1 pi. So negative 1 plus 120 gives you 119 pi over 60. And that's our angle. And like I mentioned before, the reason we do this is when we talk about trig in the upcoming sections, we like to deal with angles that are in between 0 and 2 pi. And so sometimes if we have a large angle, we have to do this first before we can actually talk about what trig value we're trying to find.